Okay, so I'm going to start with, I think, introductory assignments, introductory to Labflow. And so we're going to go ahead and start with this first question. Once again, I'm just going to go through and show you the answers. I did not realize you can do this on Zoom. So here we are. Let me see. Let me select the place to write. I wonder if I can pick the color. Okay, anyway, go with that one here. What is the correct way to report the length of the rectangle in centimeters? And so you're given different possible values here. I'm glad I have something to write with, but I don't know how to scroll down. Okay, anyway, let me try to zoom this in because it's hard to really see the graduations very well here. Okay. I don't know. I feel like the screen has frozen for me. Do I have to get out of this feature here to be able to manipulate the screen? Let me try that. Let me zoom this in. Oh, there it is. Okay, so I cannot do both. I cannot have my cake and eat it. I see. So let me zoom this in to satisfaction level. And then I will try to, okay. So let me annotate here. So you can see that the length of this box is somewhere between 15 and 16, right? So it's definitely not at 16 because you can see how this doesn't really necessarily line up with 16. Oh, there, I like the red. It's brighter. So it doesn't really line up with 16, right? Because 16 is right here and this is further out. So it's somewhere between 15 and 16. Can I scroll down to get the answer? No, I can't. Okay. When you're reading numbers from a device that has graduations, the little marks, you want to make sure you have certain digits, and we'll talk about this later on. The certain digits actually, these are the numbers that align with a mark on the device. And then the uncertain digit is the one that's between two marks. So when you have two marks, the closest marks possible, any point that ends up between these two marked points is called the uncertain one. And that's the one that you estimate or guesstimate, or we go with that, okay? So I'm trying to go ahead and scroll this so I can get to the answers. So your answer will have to be the second one here because you can actually find 15.6 here on the mark. It's hard for me to show it. And you can find, but so yeah, you can find 15.6, but then 0 will be the place that corresponds with the estimated place. So 15.6 is actually certain. And then 0 will represent the uncertain digit. Okay. So I'm trying not to lecture here. I'm trying to remind myself this is just to help you get through the problems quicker. Let me zoom out a little bit. These pictures are so huge. This might be better. Okay. Let me see if I can get an eraser here and erase this mark. Yeah, I got too zealous. Okay, close this one here. Okay. So now that we've gotten this, we're moving on. You have your explanation there. We're moving on to the next one. The next one. Okay, there. Match each element's name to its correct symbol. So you have that sodium is Na, iron is Fe, silver is Ag, phosphorus is P, fluorine. I try to say the fluo, so it's not, flour, but fluorine, F, okay? And then here you have fill in or choose the best answer to complete the table of units. So, milliliter abbreviation will be ml, property measured, that should be volume, right? Okay, I guess I just answered it myself. Let me go through here. Can I type in here? Yeah, it'd be little m, uppercase L. Property measured here will be volume. And then this would be kilogram, right? And then abbreviation kg. Oh, sorry. Oh, yeah, I think I went to the first part. Yeah, abbreviation kg. Property measured here should be mass. And then we have centimeter. And abbreviation will be cm. Property measured will be length. Oh, that's it. So you have your answers here. Correct answer. Milliliter for volume, kilogram for mass, centimeter for length. So we're moving on to the next one where it says, suppose you're measuring the mass of a solid on a balance using a weigh boat. You record the data in a table. So you have the table mass of the weigh boat. The container that's holding the mass is 2.081 grams. Mass of the weigh boat and sample, 5.660 grams. What is the mass of the solid sample? You take the large number minus the small number and you get your mass. So given these two numbers, you may get different numbers. When you subtract the small one from the big one, you should get your correct answer. So based on the numbers I have, this should be my answer right here. Okay. Once again, this video is to help those who are struggling to finish this assignment. The equation for calculating density is this one here, D equal M over V, where D stands for density, M stands for mass, and V stands for volume. Okay. So then I can select these three. Let's see what they say. Yep. Mass and volume. Okay. Last one for this. What are examples of solutions in your daily life or in your everyday life? Solutions. Okay. Correct answer. Vinegar, tea, mouthwash, rubbing alcohol. Table salt is a solid. A solution has to have a mixture. So it's a solid, so it cannot be a solution. A pure water, it says it's pure. So even though it's a liquid, it has to be mixed with something else. So it's not a solution. And then the remaining four are solutions, right? Okay, so we're done with this one here. Let's see. For this next section here, we're going to be completing a practice report with provisional data. Are you completing this online? The answer is yes. Request provisional data. Confirm. Oh, so this is the data we have, okay? I would recommend you actually keep a notebook or something and write this information down because you're going to need that. So provisional data is data that you need because you're not actually doing this experiment, right? So it says here, you will be prompted to enter. Let's see, where's my mouse? I moved my mouse. Okay. You will be prompted to enter a measurement. So this is where I'm reading. You will be prompted to enter a measurement you were expected to make within the experimental procedure. So enter the length of a rectangle in centimeters. Your measurement is 19.5. So length of rectangle, I'm going to write this down, is 19.5 and then centimeters. Width of rectangle in centimeters. My width of the same rectangle is 14.96, right? You can see the number right here. And then length of a rectangle of another student's measurement. So somebody else's length of other students. I'll put here stud for student. It's going to be 19.54 centimeters. And then this is the final measurement you will make. After entering this measurement, you will be prompted to proceed to the next section. Once you do so, you will not be able to change the data you collected. Make sure you have entered all of the data correctly. So width of the rectangle, this is the other student's width. So I'm going to put here W for the student. Sorry, W for width, and then parentheses stud for the other student, and their numbers are 14.95 centimeters. So we have my numbers, once again, to recap. Length, 19.50 centimeters. Width for my number is 14.96. For the other student, we have numbers. Their length is 19.54 centimeters. Their width is 14.95. Okay. Now we're going to start entering calculations in this section. In this section of the report, you will enter calculated results based on the data you collected in the previous section. Or if you selected provisional data, the data was automatically generated for you, right? Pretending as though we actually did the lab. In this first part, we will go over basics of entering numbers, getting feedback for correct or incorrect answers. Enter your answer to y equals 3 times x. So I'm guessing I'm going to put here 12. We'll see how that plays out. Okay. After you submit this report, you will see the incorrect feedback. What incorrect feedback looks like for this question. Wait, what do you mean? How are they assuming I'm wrong? Let's see what happens. Enter the answer to 50.0 divided by 10. So 50.0 divided by 10.0, that should be 3, right? So we'll put 3 point. Okay, so we're dividing. We have 3 sig figs. We haven't learned that part yet, but I'll put 3.00. Let's see what happens. After you submit this report, you will see what feedback for incorrect significant figures look like. oh, they're assuming my answer will have the wrong number of significant figures. That means even if I write the right number, they will mark my answer incorrect. But they're warning you ahead of time, so don't feel bad if it happens. Enter any number. You won't be graded correct or incorrect in this field. After you submit the report, notice that this entry is marked with a blue dot. Okay, so 2. Entering answers in scientific notation. Throughout this course, you will find yourself dealing with large and small numbers, or numbers where you need to be specific on what it is and what it is not, a significant digit. Using scientific notation to enter your answers is going to help you out. Okay. Enter 1, 2, 3, 0, 0, 0, 0, 0, 0 as scientific notation. Your options are the following. So I'm going to put, how many zeros do we have? Is it 6? 1, 2, 3, 1, 2, 3, 4, 5, 6. So let me write this down so I can make sure. 1, 2, 3, 1, 2, 3, 4, 5, 6. So my number is going to be, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So I moved 8 spaces. Oh, they're giving us, you know what's funny? I didn't realize they have the answers here. Our answers are, I was actually doing the technique. The answer options are here, right? It says so. Your options are the following for the answers. I was actually trying to work it out. Anyway, so I'm going to do 1.23. And I'm going to use capital E and then 8. Okay, I'm going to use that one. Enter 0.000000. So 1, 2, 3, 1, 2, 3, and then 1, 2, 3. Okay. So I don't know. I feel weird just trusting them. I'm going to go with the answer, but I want to do it myself first. 1, 2, 3, 4, 5, 6, 7. Okay. Yep, that's correct. So I'm going to do it like this. 1.23. And then capital E and -7. Okay, that should work out, right? Okay, entering units with your calculations helps you make it clear what you're answering. I should say more like what you're measuring. Anyway, or what you're calculating, right? There are some limitations on the units within Labflow. You cannot enter a degree symbol. Oh, I didn't know that. So if you wanted to enter the temperature of 21.0 degrees Celsius, you will need to enter 21.0 Celsius instead. Other limitations are a lack of a dot, superscript, or micro symbol. If you find yourself needing to use these symbols, just do your best. So if you needed to enter 1.5 micrograms, you will enter 1.5 U-grams instead. Oh, okay. Now it says enter 10.0 milliliters with the unit. So I put here 10.0, little m, capital L or uppercase L, and then I'm done with that. In this part, you will need to complete the table by looking at the initial number in column 1 and the rounded value in column 2. In column 3, select whether the student correctly rounded the value. In column 4, enter the correct rounded value. Ooh, I hope I do well on this one. When you see a table in Labflow, there is a toggle button that will allow you to enter the answers in the table format or to break apart the table and enter the answers individually. This is useful if you're using a mobile device and the table is too squished or extends beyond the screen. Complete the table below. Okay, so right here. Value 1, 243.619. Student's value 244. I guess I can say it's correct. Correct rounding. What was the correct rounding to? 244. Okay. For this one here, the number is 654900. Student's rounded value 655. Not correct. Okay. The logic I have here is imagine this was your number, right? No, this was your number, but this was your balance in your bank account. And you had this balance here, and the bank said, oh, we rounded up and gave you this amount here. You got the number you have right now, the balance you have in your bank is close to what you used to have. It's actually slightly more, right? So this is favoring you, right? This one here, say you had this in your bank account and the bank said, we rounded your amount in the bank to this. You're going to hire a lawyer, call the cops, something. You're going to make a lot of noise because they took you from 6 figures to 3 figures. What? When you're rounding, you don't want to change the magnitude, right? How big the number is. You're just trying to round up and down for consensus so that everybody who is trying to deal with that number in the lab arrives at the same final value, right? You don't want to change the whole value or the whole magnitude that you're working with, how large it is, right? This is from 6 figures to 3 figures. That is not good. So this is not correct rounding. The correct rounding should be what you would do here. If we're trying to get 3 significant figures, because it says here, I skipped over that, bad teacher. I'm trying to get through this fast without making the video too long, so I'm not really reading very critically, but it says rounding to 3 significant figures. I see it now. Okay. In that case, this position here will remain. This will remain. This will remain. So these first 3 will count towards our 3 significant figures. That means the last 3 cannot be, the digits we have for the last 3 cannot be significant. Okay. So the first one, 6 will remain, 5 will remain. And then instead of having 4, because the number to the right of 4 cannot be significant, because 4 essentially at this point will be our 3rd significant figure, because the next number is 9, we will round up and make this 5. Okay. You're probably saying, wait, isn't it the same as this number? I'm not done. So where 9 is now becomes 0 because that's not significant. Then we have the other 2 zeros. So to round this number here to 3 significant figures, the cut point is right here between 4 and 9. So 6, 5, and 4 will count towards the significant figures because they're all non-zero numbers. And then the 9 will become 0 by rounding it up. So as long as this position here is 5 or above, it gets rounded up, and then you add 1 to the number prior to it. So we have 6500. Anyway, I'm trying not to give a whole lesson right here. Okay, our goal here is to calculate the area of a rectangle. Finally, in this section, you will use the data from the data entry section, or the one above that I asked you guys to write in your notebook, to complete the calculations. Notice that the length is entered into the table already. Okay, you should stop here, right? Notice that the length is entered into the table already entered. Okay, it's not me, it's them. Okay, these values come from the data entry section, the one that I asked you guys to write down. Complete the table by entering the width measurements collected above, and then calculate the area using lengths and widths. So, this is me, right? So I already have the 19.5 written down and it's written here. What I'm missing here is my 14.96. The other student is 19.54. The other number that's missing was 14.95. Okay. So the area here is just going to be, length times width, right? So for the first one, I'm going to show you how I do it here. 19.50 centimeter, because it's centimeter, right? Times 14.96 centimeter. Okay, we haven't learned these rules yet, but we have 4 significant figures here, 4 significant figures, and here we have 4 significant figures. So once we get our number, we have to round up to 4 sig figs. Let me go ahead and do the math real quick. 291.7. So I have 4 significant figures, right? Because I have 4 sigs and 4 sigs, and so this is going to be 4 sigs. Okay, over here, I'm going to have 19.54 times 14.95. So we have 292.1. Also 4 sig figs. Okay. This one here is an essay. Essay questions are expanding text fields for you to enter your longer typed answers. There are a number of options you can use in this text field. A few of the more useful options are the following. Okay, so you can actually format text like entering formulas like water. You can insert objects, you can insert images or tables and all that stuff. So here it says this essay is an ungraded response where you can practice entering text and formatting it. Okay, so I'm going to say ZZZ, tired but pushing through. Yeah. Okay, so this is what's going to go through, saving. And then finally, we're asked to upload files, right? Take a picture of the screen. File uploads are used to collect images or PDF files you create. Your instructor may want you to take pictures of your notebook pages showing your calculations for the experiment or to document a specific part of the experiment. You can click on the file upload box and select files on your computer, or you can drag files from the computer into the box. Once added, you can delete the file. Okay, let me try this. Let me scroll down here. Let me see. I have a. Why did this do that? Can I take a zip folder? Ooh, it said no to zip. Whoa. Does it have to be PDF? You know what? I have this cute picture right here from. See, it allowed me to do the image. I can do that part and upload it. Of course, if I want to upload, I just press upload. It's a little cute picture from Christmas. Look at that. Okay. So then, of course, when you're done, you click submit. Let me pause because I'm going to try to go to the last assignment. For this last part of the assignment, you're practicing report with upload. Activity will be marked as complete on the page once you submit it. Remember, you have to complete it to submit it for this to actually be marked as complete. It says, draw a picture of a cat. Some of you did a very good job. I saved the top 3 and I was like, wow, I saved it. Draw a picture of a cat and upload the image. So you want to go ahead and upload it up here, like I did before, find it on your device or whatever, upload, and then you should be done. And that's it for this assignment. Okay. Hopefully it wasn't that bad.